Hi, welcome to this webinar on impact of artificial intelligence in financial services. My name is Vivek Singhal. I am a co-founder and chief data scientist at Cellstrat. Okay, let me just continue here. So just a plug on our startup Cellstrat. We are a leading AI startup in India, and we are very research oriented. We focus on applications of AI and deep learning, and we produce a lot of research and content in this space. And I'm very pleased to announce that we have recently launched an AI lab offering based in Bengaluru or near Outer Ring Road area. For those of you who are from Bangalore, so we are interested in collaborating with you know uh, expert AI researchers and machine learning data scientists to co-create solutions in our lab. So we are now launching a Cellstrat AI lab in South Bangalore location, which you can co-locate with us, for example, every Saturday and co-create innovative and disruptive applications using AI and machine learning. Right. Let me continue here. So just a brief intro on myself so that you have some perspective who's talking. I am a data scientist and I focus on AI, machine learning, and deep learning research and applications. I am a serial entrepreneur having run multiple startups. I was in US for 16 years. My last job in US was with AT&T as a lead technical architect. After that, I worked in IBM Bangalore for 2 years, and last few years I've been doing a couple of startups. So Cellstrat is my most recent startup focusing on AI and machine learning. Okay, so we have produced a lot of research in this area, and you can see a couple of models we have worked on. For example, house price regression, image prediction, language translation, time series, handwriting, and so on. You can find some of our research on our research portal. The link is shown there, our blog, and we also have a very active YouTube webinar channel where we record these webinars. You can check it, find us on YouTube as well. So the link is available on our meetup page, and a lot of our content sample is available on our research blog. Our AI lab information is on our website for those of you in Bangalore who are interested. Okay, let's look at application of AI in financial services. So looking at some use cases in India here, so we see a couple of banks in India, like leading banks like Kotak Mahindra or HDFC are trying a couple of AI applications. For example, Kotak is using robotic process automation or optical recognition for streamlining internal processes and digitizing the documents, if you will, and because there's a lot of paper floating around, so using machine learning OCR, you can digitize it and have fairly accurate PDF or a Word document, if you will. Okay, let me continue here, and then Kotak is planning to use this for risk management and fraud detection. HDFC Bank is using robots and Facebook Messenger bots for improving customer experiences. So concierge bots are becoming very popular. Sometimes they use Facebook Messenger, sometimes they use other kind of bots from companies like Automation Anywhere or UiPath. They have also developed two physical robotic chatbots, Ira and Eva, with help from some startups in Bangalore. We'll see an example of that on the next slide. Okay, let's continue here. So somebody was asking me about Kotak and HDFC detailed. I don't have those details. I read this information somewhere. So if you Google it, probably you can find more details. But a lot of this projects probably are confidential within these banks, and they are not willing to publish the complete case studies, right? So we have to just go by the media reporting. Uh, but we kind of know what technology they are using, so that way we are clear. We know what exactly how it works, what they would be doing. So this is just showing the IRA robot of HDFC. So previously, Industrial Revolution 3.0 was going on. Now it's Industrial Revolution 4.0. So what has changed? Earlier, you could do web and mobile banking using a mobile app or a banking website. You could easily transact with the bank. You rarely have to visit the physical branch, right? That's what happened with internet and mobility. Now with robotic assistant, it becomes even more intelligent, and you walk into the store. So this is a photo from the Worli branch of HDFC in Mumbai. Those of you who are from Mumbai, you go to the Worli branch. I am told there is a robot there, and it can do face recognition. So it can identify you or authenticate you as an HDFC customer, you using just by looking at you, and then you can talk to it. You can say, Ira, what is my bank balance? And it will show you the bank balance on that screen shown on the robot's chest there. So these are some concierge examples we are beginning to see. Hilton Hotel in the US is deploying the IBM Watson robot at the front desk to help the guests of the hotel, reach the room or the restaurant or get other information about checking in and checking out. Okay. So a question came, how are the development going in PSUs? Have any info? So, well, as you know, the state of PSUs, public sector banks in India, is not very good right now. And most of them are facing non-performing asset issues, right? Government is trying to bail out the public sector banks. So more of the innovation might be done perhaps by private sector banks. I mean, that's just sort of a high level guess I have. Uh, you know, Even when we are discussing, we are having discussions with private sector banks for different kind of AI initiatives. Some of these banks include banks like HSBC, DCB, DCB Bank, HSBC Bank, and Canara Bank a little bit. So some of them are public sector banks, but mostly we see more activity or interest from private sector banks. Okay, so we don't see as much interest from public sector, yes, because the government bureaucracy moves at its own pace. But I'm sure SBI and some of these banks are very, very big banks. I'm sure they have stuff going on, but maybe it's not published yet, if you will. So let me just keep going here. So let's look at some use cases, or in financial services industry. So we can use, for example, artificial intelligence for detecting outliers. For example, anti-money company in United States called FICO, which is the leading credit scoring company in the US. I'm using a yet again different Wi-Fi here. I really apologize for the terrible experience you're having today here. Okay, let's continue our use cases. So, you can use anomaly detection for detecting outliers, for credit card fraud, anti-money laundering operations, detecting transactions in banking transactions or otherwise financial transactions which don't follow the usual patterns. You can do market basket analysis. You can create mutual funds using automated tools. Right now, we are dependent on mutual fund managers for giving us performance. And whenever you buy mutual funds in either Sensex or Wall Street or whatever, so you are always looking at the track record of the mutual fund manager. So let me tell you, the mutual fund manager of the future is no longer a human. It's an automated algorithm. Okay. So the mutual fund manager of the future is an automated algorithm. It's no longer human. So human managers are going to have to compete with the robotic managers who probably can beat the intuition of human managers. So we will see. I think for many long time to come, there will this such systems will complement the human intuition, but eventually AI is going to overtake human intelligence, and maybe these systems will become intuitive enough to beat the human performance. So it is possible in 50 years from now, there is no such person as a mutual fund portfolio manager. It is all done with AI systems, if you will, right? And we can classify users. When we are selling banking products or stock market products, we can classify customers based on their profile. We can do better credit profiling using machine learning tools. We can recommend products based on users' purchase history, their demographic and retail transaction behavior. And not everybody is suited for a fixed deposit. Maybe some people like certain stocks. You can recommend stocks. You can recommend mutual funds. You can tailor them to individual uses. I think there will be in the future we'll see custom offerings for each and every user. So the financial products I buy will be vastly different from the financial product my husband buys. So each financial product will be customized in real time to my personal profile, and banks will target it very intensely so that they are able to increase their cross sales of all their banking products, right? Then predict credit scoring by learning from past profiles and scores of older customers. So better credit profiling, banking for the unbanked. Today we do not have any mechanism to do credit scoring for the unbanked or the rural population. So these kind of technologies will give us options to do that using other kind of parameters and not usual financial parameters, if you will. We can rank order customers and to predict propensity for delinquency or bankruptcy declarations and check credit card risk. We can do ensemble learning for discovery of latent features. So we can discover what really drives consumer and corporate financial performance. Today is often a mystery, and that is the reason we are sitting on, I think, billions in non-performing assets, and the government is having a hard time bailing out the NPA banks, right? And having to do all kinds of mergers in India and so on to try to bail out the NPA banks. So with AI and machine learning, we'll be able to forecast or predict which companies are going to go kaput or which consumers are going to go delinquent, right? So it has that power. So it's very powerful stuff, and we all in the data science domain are very excited with its potential. Let me continue here. So somebody was asking about market predictions, and here you go. So using a time series analysis, using a algorithm called recurrent neural networks or LSTM, I can do time series prediction. So in this diagram, you can see that I'm using, the last 20 samples of a stock share price. So let's say last 20 days share price, and then I'm training a model which can predict the 21st day. So this 21st day is my target prediction. So using previous 20 days share price, I can predict the 21st day's share price. Okay, and so the prediction, the red dot, is matching nicely with the 21st day prediction. So I take previous 20 days. You know uh, uh, I predict for next one day. I predict tomorrow's performance, if you will. So the red dots represent the last 19 days plus tomorrow, and the blue dots represent the last 20 days, and the star, of course, represents the target. So the target and the prediction match precisely. So we have a mechanism of predicting, house prices using this model, predicting the performance of individual stocks or shares, or equity stock. And so all kinds of asset, prediction you can do. You can predict gold prices or even, house prices or other kinds of assets, right? So this is called time series prediction, and powerful algorithms are available which allow me to do that. Okay. So somebody is asking, how do you validate the accuracy of such models? So as I said, stock market prediction, gold price prediction, oil price prediction, these are still work in progress algorithms. So if these algorithms would be perfect, I would be retired now, right? I would have cracked the stock market and the gold market and oil market, and I would be retired now. So I'm not yet retired, which indicates these algorithms are not perfect, right? Even Goldman Sachs is trying to figure it out. So you see, predicting stock market is extremely difficult because it doesn't have 100 parameters or 500 parameters or how it has probably lakhs of parameters. So that's why they have not cracked the stock market prediction, because it has infinite number of parameters. And when there are so many variables involved, it's really hard to develop an algorithm which can accurately predict stock prices. But Goldman and JP Morgan and Bank of America and their ilk, they are getting better at it. They are trying a time. And so, this is what I say. So in future, what will happen? The stock prediction managers, all those experts you see on the television media who are forecasting stock performance, those guys will not be competing among each other. It would be algorithms competing. So it will be the algorithm of Goldman Sachs versus the algorithm of JP Morgan. So it would be algorithms competing, not humans anymore. All such guys who claim to predict stock market, they will become redundant or unemployed, in 50 years from now. It will be the battle of the algorithm, not the battle of the predictors, if you will. Okay. So Goldman Sachs will say my algorithm is better. JP Morgan will say mine is better. You know, or HDFC Bank will say mine is better. So there will be a battle of algorithms. Can we predict bitcoins also? Absolutely. Any asset price you can predict. You can predict Bitcoin and cryptocurrency. Absolutely. So that's why in blockchain and crypto we find a major use of artificial intelligence. I don't know anything about it personally, but I know that blockchain industry is using AI. I know that. So I've received this question many a times that are you working on blockchain also combined with AI? I'm not working on it, but I know they are using AI. You can predict any asset price. You can predict gold, oil, or futures and commodity trading. Agricultural prices, all kinds of stuff you can predict. All right. So you can try to predict. Obviously, it's not very accurate as we said, right? So there is some because the variables are inevitably too many. Okay. Now let's go a bit deeper and look at some more case studies on a more deeper level, if you will. So we look at two of these use cases here. So you can see how we could use machine learning algorithm, for example, credit worthiness or credit scoring of customers, right? How we can use it for investment banking. As I said, today we have investment bankers who are trying to figure out good asset allocation, but we'll see how we can do it better with machine learning and deep learning. Obviously, you can use it for fraud, or for credit card fraud or money laundering or other kinds of financial fraud. And of course, you can use it for sales and marketing. I'll show you a demo today where I'll show you how to predict whether a customer will buy a banking deposit or not. I'll show you a coding demo where I'm able to predict whether a customer will buy a banking product like a fixed deposit, yes or no. So using historical customer data. All right. So let's continue here and look at some of these case studies. So a question came, how can we predict Bitcoins? So, it would be time series prediction, the one I showed you in the previous slide. If you were to give me Bitcoin data, what I would do, I would ask you for historical Bitcoin data. Let me just go back here. So, I'll ask you for historical Bitcoin data over, let's say, last few years or last 1 year, whatever is available. And I try to apply a time series RNN model to predict future value of Bitcoin. But it's quite hard. See, Bitcoin is probably even harder because there is no rules around Bitcoin, right? It's all, no government recognizes it. Most of the central banks are clamping down on Bitcoins as we know it. So predicting Bitcoins may be even harder because it is in the gray zone, right? It's not an official currency yet anywhere, right? And most of the central banks are not letting it, percolate, if you will. So it may be even harder because the factors which influence Bitcoin are even more abstract than at least for a share or a stock. I have more public information. It's a well-defined product, a share of Microsoft company or share of Google company or share of ITC or even the ICICI Bank share itself. So those things are slightly more well-defined. Bitcoin may be harder because it's in the gray zone, right? It's not even well known. There is not enough information. So more abstract the asset, the harder it is to predict. More the number of variables, harder it is to predict. That's how the logic goes. If there were only well-defined 100 parameters to determine stock price, it would be quite easy to predict the value of the stock. But there are not 100 parameters. There are infinite number of parameters which influence stock price. Hence, it is not so easy to predict it. Okay. With Bitcoin, it's infinite things which influence it. I mean, we don't even have all the information on Bitcoins to do a good job of it, but you can try. Okay, let me continue here. So let's look at one of the use cases on a more in-depth level. And I'm interested in credit profiling here in a more sophisticated way. So this is the current. The point of this slide is this is the current way with credit decisioning is done. Some of you who are from banking probably can, I'm sure are much more expert on this than what I am able to indicate here. I'm not a financial guy, but my understanding is this is how you do current credit decisioning. You may be looking at their payment history, for which will give 35% weightage. We are looking at how much credit I used. If I have a credit limit of 1 lakh rupees on my American Express account, but let's say I'm using 40,000 only per month from my MX card, right? So, so I may give that amount of credit used as a percentage of overall available credit, 30% weightage. Length of my credit history, right? So, how long I have had a credit profile, in a company like Civil or in the US with Experian, let's say, and frequency of new credit, how frequently I apply for new loans and credit card products, right? And types of credit, whether I have a housing loan, a car loan, a boat loan, or what kind of credit cards I have, right? And other personal loans and so on. So, so you may be applying a cookie cutter formula where you just give these respective weightages to these factors, if you will, and then you decide that, okay, well, based on this formula, you have created a formula with these weightages around these factors, and you create their credit score. Is this very scientific? Definitely not. Is this very personalized to a user? Definitely not. You are applying the same cookie cutter solution to the entire population, but no two people are alike. So if you apply a cookie cutter solution, your credit score will not be very indicative or accurate, right? Let's see what happens next. So you will create a score using those previous parameters, and the appropriate weightage is assigned to each parameter. And you say, well, if you have less than 500 score on my calculation formula, then it's very bad credit. 500 to 640, you have bad credit. 640 to 700, you have average credit, and so on. So this is a cookie cutter formula you are applying to every person who walks into your bank. We have one more problem. If you have poor score, let's say it's a new user, they don't get a loan. Since they didn't get a loan, they don't even have a credit card. They do not create transaction history. No relevant transactions exist in the system. There is no credit history. No credit history leads to poor score. We are stuck in a vicious loop. That's what happens with a rural customer today. They don't have a bank account. They don't have a credit card. They do not have any digital footprint in the credit or financial world. So you don't issue loans to the rural guys. But many of the rural guys have good ability to repay the loan. But you don't issue them the loan. So you're missing out on a massive market chunk. If you're a bank, you are ignoring the entire rural population. Many of them can be good, creditors. They can give back the loan. They are quite rich, some of them, right? You do not have a way of tackling this problem. If your child graduates from college, they don't have any previous credit history. They just start with a new credit card, right? How does a teenager which enters into the working world build a credit profile? When I went to the US, I didn't have any banking history in the US, so they won't issue me a credit card. So I had to give some collateral to get my first credit card in the US. So they said you have to keep, let's say $5,000 logged in the bank for Bank of America to issue me a credit card. So they logged $5,000 of my savings, right? So this is a circular logic problem. How do you solve this? So some of this can be solved with machine learning, okay? So what is happening? There is no personalization in credit scoring. One size fits all credit scoring model does not account for individual behavior. We already said that. It tends to target people who do not need credit. So all the banks call the same 1% of the population. I mean, we get telecalls every day, right? Whole day long, we get 5 calls from 5 different banks, hawking products for card, for personal loan, and so on. Why? Because because we are the only people they have profiled. They don't have a way of profiling 99% of the population which doesn't have transactional digital footprint. So that is the reason so many startups are coming up. Alternative lending, so many alternative lending, peer-to-peer lending, or companies like Paytm and other companies like MobiKwik and dozens of others are coming up, which are capitalizing on the weakness of credit scoring model, which the traditional banks don't have a footprint. So So these other, alternative lending companies are coming up. SME lending, like Five Star Finance, right? Many other such companies which are coming up, which are providing, and a lot of them are using artificial intelligence for creating credit profiles, okay, or using different other parameters apart from usual transaction history, which doesn't exist. So the question is, how can we do credit scoring in a more analytical way? What parameters do you think can influence credit worthiness? So well, we'll look at a programming code shortly to see how this could be done. But before I go to programming, let me present another use case for you. How about investment banking? You know, so today what happens that this is the current investment banking process. A mutual fund manager or from Kotak Securities or whatever. So they shortlist stocks based on past risk and return. Even though it says the past performance is not an indicator of future performance, but still they are using the past performance as the only thing they can rely on, right? They study the publicly available balance sheets and income statements on Ministry of Corporate Affairs website, right? And they seek opinion from customers and suppliers of that company. Let's say ITC, or Procter and Gamble or Nestle. So I'm talking to their customers and suppliers and seeing how they feel about that company, right? So I'm using all of these manual, processes to form an opinion about a company. Then we have a model which model returns to take buy sell call. So this is how today the investment bankers are operating, right? Fairly manual process, fairly intuition driven, right? No scientific way of doing it. They are missing on host of other factors. What are those host of other factors? Let's see some of them. Well, here are some host of other factors which might, influence a company performance, right? Which might influence a company performance. How about using satellite images? Check this out. This is a satellite image of a parking lot in front of a mall. This is the satellite image of a, how green the crop is. Let's say I'm in the wheat season, so this could be a satellite image of the wheat farm. I could have thousands of such satellite images, and I can bring this kind of satellite imagery as a factor in my calculation. So if the crop is green, my agri product companies like ITC and others will do well, right? Crop is green, and the prices of raw materials for food and beverage industry will be lower, right? If the crop is good, number of cars in a shopping mall indicate good economic performance of the nation, and more people are visiting the malls and buying products. So this influence, probably I can take that into account for my retail predictions, how retail companies will perform, or real estate companies will perform, right? So all of this information can be used for modeling company performance, not just those other factors we saw on the previous sheet. How about looking at email forensics? So doing document detection, like natural language processing to read emails and other kind of invoices which are being issued. So we can do email scans and see how the companies are performing. We may find some useful information from email and invoice forensics or document forensics. We'll be using NLP to find useful tags or keywords within these documents. How about looking at satellite images of ships in the ocean, or the state of an oil rig? If all of our oil rigs looking healthy from satellite, we can assume the oil industry is doing fairly okay, right? If half of the oil rigs are in shutdown mode, which you can see from the satellite, then then it indicates the oil industry is having some stress and its oil industry is not running at capacity, right? Number of ships in the ocean, you can count the number of ships in the ocean, that might indicate something. And scanning Twitter feeds and then social media sentiment, right? Regulatory compliance, we can check which banks are having trouble because of social media postings. I mean, we'll have to modulate or dilute some of this information because it may not be very indicative. If somebody is, let's say lambasting SDFC Bank in social media, that's not very reliable. That could be just some disgruntled customers, right? But still, it could be a minor factor in our calculation. So obviously, SDFC is not doing a good job of, maintaining their public relations with their customers. That's why people are lambasting their customer service in the social media. So all of this information could be brought into your investment banking formula, which it doesn't take into account today. And all of this will need deep learning solutions, right? Okay, so before I come to my last segment, which is some career counseling we always like to do at the end of our webinars, I like to show you some real programming models. So let me start my programming template here. So those of you who are developers will probably understand this, but those of you who are functional, in nature, you can just understand it logically. You don't have to worry about the coding aspects of it. I'll just start my programming editor to demonstrate, how we could do some of these calculations using machine learning. Okay, so this is my programming editor. Let me just invoke the code I'm interested in. So, let's just see the data set first. So, most of the good machine learning models rely on some kind of existing data, like from RDBMS, Oracle, or SQL Server, or Microsoft Excel, or something, right? So I'm looking at a banking product application. So let's see what this data is looking like. So, it has demographic data on a bank's customer. So for example, age 30, blue collar worker, he's married, he or she, and they have not defaulted, they have housing, uh, they don't have housing, they have a loan, yes. Do we have their contact information, cellular, and so various kinds of demographic and personal information is available in this data set for, let's say, a couple of thousand customers. And in the end, the last column contains whether this particular customer bought my banking deposit product, yes or no. Did they buy my fixed deposit, yes or no? So there are like 20 parameters which influence the purchase of the banking deposit, the customer demographic profile, and the last 21st parameter indicates whether this particular customer bought my fixed deposit, which I launched last year, yes or no. All right, so the last information will always be yes or no. There are a lot of yeses, but you'll see there are a lot of no's in the end, but you'll see a couple of yeses here, right? As you can see, let me just expand this so you can see this data set clearly. Right? So in the end, you will see a couple of yes, no, right? So if it says no, this customer did not buy a banking product. If it says yes, the customer bought the banking product, and the customer demographics is in the previous field, right? What is their education, whether they have a phone, cellular or not, and so on. So some other kinds of information, right? So this is the data set we are using to train a, a logistic regression model which can predict whether my future customers will buy my banking deposit product, yes or no. So this just shows the algorithm what those features mean. So the first feature is the age in that 20 feature list. Second is the job, what kind of job they have, right? Are they admin, blue collar, entrepreneur, housemaid, management? Marital status, educational category, right? And then default, has the person been in default in the past, credit default? Do they have a housing loan? Do they have a personal loan? So you'll see a lot of personal information, if you will. There are 20 such parameters, as I said. The 21st parameter is the output variable. So the first 20 are considered as input variables. The last variable, the 21st parameter, is considered an output variable. And that basically just says value yes or no. Did the customer buy my banking product or did not buy my banking product? All right. And what I do here is I run this logistic regression model, which is a classification algorithm. So I'm just printing some initial data, which you can see here. Those of you who are developers probably can relate to it, but those of you who are not, don't bother, just understand logically. Okay, I'm doing categorical transformation. See, machine learning does not understand words like, good, bad, yes, no. I have to convert everything. For example, this word blue collar. Machine learning doesn't know alphabetical language. It only understands numerical language. So I will give it a label. I may say blue collar means 0. Services job means 1. Admin job means 2. Marital means 0, single means 1. You know, contact cellular do they have a cellular phone? Cellular means 0, telephone means 1. I'll have to do numerical encoding of all such categorical data, which is what I'm doing here in this part of the code. Those of you who know Python, I'm sure are used to this, but others can understand just functionally. Okay, so then actually, I am dropping some columns. So I am only going to use a subset of the 20 features, not all 20 features in my model training, just for simplicity purposes for now. Okay. And then we what we do, let's say we are given 5,000 rows, so we might keep 4,000 or 70% of these, approximately 3,500 for training, and 70% for training and 30% for testing. That's why I'm doing a data split. I'm saying I would like to reserve 30% of this data for testing steps, so that I can test it using new data which it is not trained on. Because a class teacher will never teach all the problems to the student. A class teacher will always keep one secret problem or two secret problems for the final exam. The same exact mechanism happens here. I reserve some data for the testing step. I do not use it for training step. And that is why I create separate XY training and test data. What is my X? X are those 20 features, but now I'm using, I think, 6, 7 features. What is Y? Y is whether the customer bought the bank deposit, yes or no. So Y is one feature, and the input is couple of features. Okay. So I'm using logistic regression, which is a popular classification algorithm, and I train a model, and you can see the output here. So I can predict whether customer will buy a banking deposit, yes or no, with an accuracy rate of 0.91 or 91%. So I have now trained a model here which can predict with 91% accuracy whether a future customer who walks into my bank will buy my fixed deposit product, yes or no. Right? Because bank wants to always do capacity planning. It wants to find out how popular this product might be, how many sale of this product we can expect next month, let's say. Right? How many FDs I am going to sell next month. So I can use this kind of logic to make that prediction. So I have a model which can predict with 91% confidence level whether a certain new customer will buy a banking deposit or not. All right. So this is how machine learning can be used to solve this deterministic problem. Okay. So that was bank marketing example, how a bank can determine which product will sell and how much is the chance of selling. Correct. And this is a code for credit profiling, and let's look at the credit also. So this is a data set about consumer credit, and it has many features, as you can see. And the first column indicates whether they have good credit, bad credit. So if the first column is 1, they have a good credit. If first column is 0, they have bad credit. Okay, it's just a yay or nay decision. I'm not doing credit scoring here. I'm just trying to say whether the person's credit profile is good or bad. That's all. Just a yay or nay decision. I'm not really doing credit scoring here. I'm just trying to say customer credit is good or bad. If it is bad, we put value 0 here. If the credit is good, we put value 1 here. All other columns contain other features of that customer or consumer. Okay, and we'll see the program and we'll see what each means. So you can see here these are the definitions of those. So the first column indicates credit status, good or bad, yes or no. The next few columns indicate whether, so there are 21 columns again. So the first column is a good credit, bad credit. The next 20 columns indicate whether that customer, what is their information, what is their profile, do they have a checking account, for how long they have had a checking account, do they have credit history, what is the purpose of loan they applied for, what amount they have in the account, do they have a savings account, are they employed since what date, and so on. So there are a lot of information about that consumer which is given in the last 20 columns. The first column is merely indicating whether the person has a good credit or bad credit. That is my data set. And I am printing the first few rows from that data set. So this is first 5 customers in my data set. I mean, each row represents one customer. All right. Again, I just split the data and I say I'm going to use 70% of the rows in that Excel sheet for the training and 30% for testing. Okay, so this is how I split using the scikit-learn command called train test split, because I want to keep some data aside for the testing or evaluation step of my train model. Clear? Then I create something called MLP classifier. So this is a neural network. MLP is multi-layer protocol, perceptron, multi-layer perceptron, and this is a kind of neural network, artificial neural network that has multiple layers it creates internally, and we train a neural network, a deep neural network. That's why the word DNN with multiple layers. And now we have trained a model which can predict a customer having good or bad credit with a confidence score of 75%. Okay, so it's not very good score. Ideally I would like my accuracy to be hovering around 95, 98%, right? So not a very good score. But why this is because maybe our model is not so sophisticated, or our model needs to be tuned more, or we need more training data. So if the accuracy is low, we can do a couple of things. We can feed more training data, because less training data means less accurate model training. Or we can change the algorithm, or we can try to tune the same algorithm. We call it model tuning process. So so these are a couple of things we can do to try to improve the accuracy of our model. Okay. So these were 2 examples. I hope you understood them. Let me take up some questions now. Uh, how can we find if out of fraud when account details are compromised? Well, there will be some patterns, right? So we can do outlier detection. So, so if account details are compromised and fraudsters or tricksters are using my personal bank account or my personal credit card, so pattern, you have to find patterns, right? So it's outlier detection. So we can use some algorithms around outlier detection. It can predict this credit card is in the hands of miscreants and being misused, right? So there you can build security solutions like that. Is acceptable accuracy about 5 sigma? So this is around project management, 5 sigma. I am not good at that stuff, so I'm not going to be able to comment on it. Is accuracy here? Accuracy is the accuracy we print of the model. So how to apply, project management 5 sigma methodology? I'm not sure. Okay, so that I cannot comment on. I'm not good at project management. How do you normalize the value? Well, there are a couple of, so there is a data pre-processing step. We normalize using different algorithms like scaling and normalization. Okay, so there are different techniques, for standardization and normalization of data. So that is left for the data preparation chapter. If you go to our YouTube webinar channel, there is a webinar on data preparation, data pre-processing. There I have discussed how do you scale the data. We call it feature scaling, and there are 2 techniques I have discussed: normalization and standardization for feature scaling. Okay, you can check that webinar. Data will not be in CSV. How will it be worth with, let's say, 1 terabyte of data? Excel will not help. See, if you have 1 terabyte of data, fantastic. That means you are coming from a large bank, I assume, and you have 1 terabyte of data. So clearly, we'll be running it in batches. There is no memory chip in the world probably which can load 1 terabyte of data and process it, right? So we'll be doing batch wise. So if there is 1 terabyte of data in your RDBMS, let's say, or flat files, we'll be loading data in batches. So we'll run multiple batches of model training, if you will. We will not be loading in Microsoft Excel file or spreadsheet with 1 terabyte of data. I mean, you could technically, but we'll have to see if Microsoft, crashes if you load that much data in an Excel sheet. Okay. Okay, value like amount of loan. Sorry, I don't understand the question. Uh, more data is needed, yes. How will you define percentage train and test split? Well, generally the rule of thumb is 70-30, 75-25. Sometimes you may keep 90% for training, 10% for testing. We generally, you can say 80-20 ratio. So 80% for training, 20% for testing. There is no specific rule. We try to use most of the data for training and some amount of it for testing. Okay. Are these sample use cases available shared in public domains like GitHub? Lot of this code, it did come from GitHub. Okay, so I modified, but yes, you can find a lot of this code in GitHub. If you were to join our training courses, I'll be emailing you these code sets along with your coding assignment, of course. So yes, we have a training program we'll talk about in a second. Okay, next question is parallel processing. Multiple systems can be done for model training. Well, there is a concept of parallel processing, and there is a library we use for deep learning which is called TensorFlow, originally produced by Google, now in open source domain, available for free general GPL usage. And TensorFlow can be run on distributed mode. Okay, so TensorFlow can use multiple systems to distribute processing, complex processing across multiple servers and chips. This is called distributed computing in machine learning. Okay, so we have distributed computing available for parallel processing, if you will. There's a question: ITB can be done using that? Yes. So it I assume 1 terabyte can be done using that. Yes. So if I'm doing 1 terabyte of data, I would be using some kind of distributed computing. Indeed, I would have to spread the processing on multiple servers and GPU devices, right? So there's a mode of TensorFlow software called distributed mode. We can use that. Okay, okay, any other technical question before I come to some bit of career counseling, if you will? Okay, so in interest of time, let me just keep moving. So at the end of my webinar, I always discuss some career counseling. So we have a very robust program around training, machine learning and deep learning scientists. I'll tell you about it. So there are two kinds of career tracks here, right? So if you are a developer, then I do recommend you follow the technical career track. You could be having coding experience in any programming language, then you can become a technical data scientist. And in data science, there are multiple domains. For example, big data, Hadoop, Spark, Kafka, Hive is still hot. Nothing wrong with that. But I focus on the most glamorous part. Me and my startup, we focus on artificial intelligence, under which we have machine learning and deep learning. Okay, so I would recommend you leapfrog to the most glamorous part of data science, which is machine learning, deep learning, AI. Within this areas, there are other specializations like predictive inference, computer vision, text and NLP, robotics, and driverless cars. Right. So this is a vast area. It takes 1 to 2 years of good amount of learning courses and practice on projects to become an intermediate level data scientist. Okay, and if you are not a developer, you can still do the AI for managerial training. You can still become an AI specialist, and you could be a consultant. You could be a program manager, could be a QC person, a technology marketing guy, or sales and ops, or even HR and other folks. All of you can still become an AI specialist, or not only developers can learn AI, even non-developers can become AI specialists. Okay, because in an AI company, you still not need those other functions who understand AI, on a specialty level, if you will. You can go on here. So these are the courses we are offering. Currently, we just finished a batch on machine learning, but you can do our machine learning course. We have a self-paced mode, so you can be anywhere in the world. I'll be sending you videos and programming assignments which you have to do, and I'll be checking your programming assignments. So you can do, the machine learning course in self-paced mode. Then there's a 1 month gap for practice and projects. Then you can enroll in a deep learning course which will start on November 13th precisely. 13th of November, I'll be teaching it live every Tuesday and Thursday evening hours of India, 7:30 to 10:30 p.m. India time. So, but there is a prerequisite: you cannot join the deep learning course until you do the machine learning course. Our third course in this series is Advanced Neural Network, which will cover CNN, RNN, auto encoders, advanced stuff, and this will start in end of January. Okay, end of January. So it's almost a 6 month journey. And so, as I say, it takes about 1 to 2 years to train an intermediate level data scientist. And if you do a 6 month program, we'll give you a jump start in this area. So if you try to learn this stuff on your own, or you use platforms like Udacity or Coursera, it will take you 2 years to master this much stuff. The advantage of instructor-led coaching is you can learn the same amount of knowledge in 1/3 of the time. Okay, so that's the difference. It's very hard to learn this stuff on your own on Coursera, Udacity. Many folks who enroll on our courses have already tried those things. They could not understand, then they join our courses. Okay. You can sign up for our courses from our meetup page. You will find all the links. Each of the three courses carries a certificate, and if you do all the three courses and you pass all these are graded. I'll be giving you your grade on a like a scale of 1 to 5, if you will. And if you pass the courses, we issue a PG certificate in artificial intelligence. Okay. So this 6 month thing will jump start you, but you still have to give another 6 months to 1 year after that of continuous practice to become an intermediate level data scientist. And you know the salaries for data scientists are through the roof. It's the most lucrative career in technology in the world today. So we like to say we create AI superstars, and we mean it. So that's why we don't assign any junior trainers. I myself teach these courses and some of my very senior data scientist colleagues, because the trainer qualities makes a massive difference apart from the course quality. Okay, so very intense courses, and some of those who are attending our current courses can attest to it probably. So this is a curriculum for our ML course, which it's quite an intense course spread over a 2 month period. Starts with intro to AI and machine learning. Then I actually have a full session on maths basics, because everything is mathematical here. Optionally, we can take a Python refresher class. Then we go to various algos of machine learning. Okay, and it comes with a lot of resources. For example, programming demos in the videos, online instructor-led videos. There are hands-on exercises for you to do hands-on coding work, and there are multiple choice quiz for to check your knowledge. There are multiple capstone projects at the end of the course, and me and my fellow senior data scientists are teaching this course, and you can be part of our community if you join these courses. And the link is shown there to sign up, but you can also find this link on our meetup page. The next course we'll start in November is deep learning, but for that you should first finish your machine learning course, which is all available even now in the self-learning mode. Okay, so self-learning mode you can do ML, and then deep learning you can join on November 13, where I'll be teaching it online, live instructor-led sessions. And this is a flow, so we teach about basics of neural networks and artificial neural networks, and how they are trained, how they are optimized and regularized. Again, same kind of learning resources, so you get an intensive experience. So I'm very pleased to announce the launch of our AI lab in Bengaluru, and we are situated at RMG EcoWorld, which is near Outer Ring Road, Bellandur area in South Bangalore, southeast slightly. And we are inviting expert AI data scientists and researchers to co-create disruptive AI applications. So we want to compete with the likes of Google and Amazon, and I'll go ahead and go on a limb and say that. So we are creating a world-class team of data scientists in our AI lab, so we can create some really disruptive global applications and launch for global marketplace. Okay, and we have a very strong marketing channel, things like these webinars and our otherwise content marketing effort on LinkedIn and various social media. We have a huge online following on social media, so global customers are following us. So once we show them a couple of good POCs, I'm sure we can sell a lot of solutions to global clients. So that was the session. Now let me come to any questions which are coming up. Okay, so there's a question here. How is the salary in dollars for a technical data scientist? Well, there is no limit. I have heard in Silicon Valley, if you are expert in machine learning, $1 million in Silicon Valley. I don't know about European cities. I'm sure in prominent European cities like Rome or London or Paris, salaries are again some of the best. But I do know that in Silicon Valley, $1 million salary is normal for an expert machine learning data scientist. The keyword is expert. If you are expert in machine learning and deep learning, you can bargain for a $1 million package in India. In Bengaluru, India, 1 crore package is quite easy. If you are expert in machine learning and deep learning, the top companies like Amazon, Flipkart, and many others will pay you 1 crore package. Easy. If you are a chief data scientist in a company like Ola, Cabs, or in Flipkart, they might even pay you a multi-million dollar package in Bangalore. Okay, in Bangalore you can get multi-million dollar package, but you have to be chief data scientist. Normally these kind of people are For example, Google Fellow or IBM Fellow, PhD in machine learning from Stanford University or Indian Institute of Technology. So the chief data scientist in a Flipkart is very high profile data scientist, and they could be getting a multi-million dollar package here in Bangalore. Salaries are not at all a problem. Learning is the problem. This area is hard to learn. That's why we have a very intensive learning process we are going through right now. Since the talk is about AI in financial industry, can you talk about use case for financial auditing, accounting? See, so for management reporting or financial accounting, which chartered accountants might do, I mean, probably I'm not sure where I would use AI. AI is used for predictive modeling, right? So if you want to do reconciliations and predict any problems or detect any problems in your reconciliation process, for example, your quarterly accounting reconciliation, maybe there we can use machine learning to predict any problems or find any issues. For usual financial reporting, which for example, reporting my just producing my balance sheet or income statement, straight management reporting, I have to think, we have to discuss one-on-one and see if there are good use cases we can find there. So we're talking to a couple of accounting groups in different banks right now who are interested in using artificial intelligence, machine learning for accounting business process. For example, reconciliation or settlements or management or regulatory reporting. So we'll have to understand the use case better and see where ML can help. Okay. If it is simply reporting, it may not help, but if there is some inference or prediction, it will help a lot. Okay, any final questions for this session? We are 10 minutes over time. Thanks for your patience. I'll give you another 30 seconds if you have any final questions. This webinar has been recorded. It will be available on our YouTube channel. So great to be in touch with you. I likewise, thanks for attending, and hope to connect with you one-on-one. Feel free to reach out on all of our channels. Happy to talk to you and discuss your use cases and if you can help somewhere or help brainstorm. All right. So I am seeing most people are good. No further questions. I'm available on LinkedIn. Certainly, you can connect me there. My contact details are available on our meetup page. You can connect us there as well. Okay, thank you very much for your time and excellent questions. And I hope to see you in our next webinar this coming Thursday, where I'll be discussing a couple of classification algorithms. Good night.